let's talk about feature methods. The feature methods are very simple to declare and define. What you need is @feature annotation. So whenever you want to make a method as feature method, just simply use this @feature annotation on top of it. But there are few things that you need to keep in mind. The feature method runs in its own thread or in its own transaction, very similar to any other asynchronous operations. And this feature method doesn't execute in real time. It will only execute when the system resources will be available. It could execute in the next minute, or it can take up to hours as well for the system resources to become available and execute this feature method. Along with this, you need to keep few things in mind while you define a feature method. These methods must be static, so you cannot remove the static keyword from the method signature if you want to declare it as a feature method. And these feature methods cannot return any type of data, so the return type must be void. And also the parameters that you define within these feature methods, they must be of primitive data type or collection of primitive data type. And I hope you remember the primitive data types from the earlier lectures of this course. The primitive data types includes your normal data types like ID, integer, long, string, and so on, where non-primitive data types includes as object or your custom and standard objects in Salesforce, or even your class object types as well. So you cannot use these non-primitive data types while you call your feature methods. Now let's go back to our Salesforce org and we will see a quick example of how you can run a feature method. Okay, let's start by creating a new Apex class. I'm going to name this class as lead asynchronous. I hope my spelling is correct. Now within this class, I'm going to define two feature methods. The first method is to update existing lead records, and the second method is to create new lead records. So while defining these methods, you need to keep in mind that these methods must be static and they must have void return type. Now, in order to make these methods as feature methods, what you need is @feature annotation. So let me copy this annotation on my second method as well. So that's it. Now we have two feature methods ready. Now within this update lead records method, what I want is to update some existing records. In order to update these existing records, you need to get these from the method caller. So there are two ways to get it. Either you can get these records directly using the as object or maybe your standard or custom objects, or you can get the ID of these records and run an SQL query within these feature methods to get it and update those. So if you get these records directly, maybe like list of as object or maybe list of lead, and let's name it as existing records. And then maybe like we can have a for loop running on these existing records, and I simply want to change the lead source for these records. So it will be like record.lead source equals to web. Once I'm done and once I'm out of this for loop, I'll simply call my update statement on these existing lead records. So do you think it will work? It won't, because if you remember, these feature methods can only accept primitive data types. So here we are seeing our error which says feature methods do not support parameter type of list. They do support the parameter type of list, but they do not support non-primitive data types. So as soon as you change it to ID, it will work. What you need now is to use these IDs, maybe like I'll name it as existing record IDs, and then I'm going to get the list of existing records. I'm going to name it as existing records only with the help of an SOQL query. This way I can get my existing records, and now I should be able to process over those and update these existing records. Now let's try to save it again, and I do not see that problem anymore. So always make sure that you are supplying the primitive data types in your future methods. And the reason why it doesn't accept non-primitive data types is, like, if you pass these lead records directly to this future method, by the time this future method executes in future, which Salesforce doesn't guarantee when this will execute, maybe these records will get updated. In that case, you will lose your database integrity because you will be updating a record which is already updated by someone else in the meantime. So that's the reason you can only accept these primitive data types, and then here you'll get the latest values of your records with the help of this SOQL query, and then you update it. Now in the second method, what I want is I want to create some lead records. By the way, just treat it as like this is some kind of heavy operation, and that's why you are writing it within the future methods. Else you could do it inside your normal methods as well, but in order to demonstrate how the future methods are used, I am writing it within the future methods. Now in my second method, I want to create the lead records. So let me copy the code from one of our previous example, and this method is simply inserting one lead records. Again, treat it as some kind of heavy operation, and that's why we are writing within the future method. And this is something that we always need to assume while we are going through this async Apex section of this course, because it's hard to find the real use cases of these async operations. You will only see it when you will be working on a project. So now I'll simply save this code, and now I'll call this update lead records method from my anonymous window. So let me erase everything. First I'm going to get all my lead records, and here let's write our SOQL query. And now I'll use my lead asynchronous class to call my future method, which is update lead records, and here I'll pass the key set of this map so that I can pass all the IDs of these lead records, and I'll change this method to accept a set of ID instead of list of ID. So now let's call it, and it's working fine. Now let's go to logs, and here we see two different logs because there were two different transactions that were executed as part of this process. The first transaction was the synchronous process, which was this line of code, and the second transaction was the future method, which is this one. So whenever you are executing an asynchronous code, you will see multiple log files because they will be different transactions. So if I'll open my first log, it will not have any type of future method entry. So if you search for maybe future here, you will simply see that number of future calls from this transaction was 1. Now let's open our future methods debug logs, and here we will see our actual execution of future method. So I'll simply search for the limits here, and you will see that one SOQL query was executed in this future method, which returned 1044 rows, and we updated all those 1044 rows with the help of one DML statement. Now this all worked fine, and we were able to update our future methods. But what if I want to call my second future method from this method? Is it possible? Let's try it out. Let me call this second method from here, and let's save it. So we were able to save our code. Now let's try to execute it. And here let's go to our logs, and we see an exception which says future method cannot be called from another future method. So keep in mind, whenever you are calling a future method, you cannot call any other future method from that particular method. And this doesn't only apply to future methods. If you call any other async operations from future methods, it's not allowed. For example, let's say if you call a batch class from the future method, it is not allowed. You cannot do it. And the same thing applies to your scheduled class or queueable class as well. You cannot call any type of async operations from the future methods, and that's a hard limit which you cannot overcome. But you can call multiple future methods from a synchronous transaction. If I remove this line from here and save my code, and if I call this method from here, we will be able to do it because this part of code is synchronous and we can call multiple future methods from here. What we cannot do is calling one future method from another one. But here it's totally fine and you can execute this one. And this time we will see 3 log files. 2 for 2 future methods and 1 for the synchronous transaction. So here it is. We are seeing 3 different files here. 1 for the synchronous transaction and 2 for 2 different future methods. So that's all in this video. In the next video, we are going to talk about Batch Apex.